In this video lecture, we'll be using the brute force method to find a solution to a classic traveling salesman problem. This businessman must visit customers in 5 cities, A, B, C, D, and E. A is his hometown, so he must start and end at A. He doesn't want to spend more money than he has to on this trip, so he wants to find the cheapest tour. This is what we call a classic traveling salesman problem. We are looking for a Hamilton circuit, a circuit that visits each vertex exactly one time and returns back to the starting point. Notice that this is really the complete graph K5. We have 5 vertices, each connected to every other vertex in the graph. Our edges represent flights between one city and another, and the cost of those flights are labeled. What we need is the Hamilton circuit that has minimal cost. With K5, there are 5 minus 1 factorial Hamilton circuits. That means that we have 24 circuits to consider in order to be absolutely certain that we have the one with lowest cost. But recall that 12 of these circuits will simply be the reverse of the other 12, so we really need to check 12. Starting at A and returning back to A, here are the 12 tours that we need to check. We'll start with the simplest case of going from A to B to C to D, E, and then back to A. I like to work in a methodical order to hopefully prevent missing a tour. So for my second tour, I'll start by going A, B, C, but then I'll switch the last 2. I'll go to E and then D before returning to A. Notice that those are my 2 options that start with A, B, C. Now I'll list my options that start with A, B, D. After A, B, D, I could go to C and then E and back to A, or I could go to E and then C before returning to A. Those are the 2 options that start with A, B, D. Let's move on to the 2 options that begin with A, B, and E. With these 6 routes, we have all options for starting with A, B. So we'll move on to the options that begin with A, C, being careful not to write down any circuits that are the reverse of any circuits we've already written down. Looking in reverse, we already have 2 circuits that would begin with AC, so we'll be careful to avoid those 2. Now we'll finish our list of 12 tours by listing the final 2 that begin with A and D. If we look in reverse, notice that we already have 1, 2, 3, 4 that take care of options that begin with A, D. So there's simply 2 left. Now we have the 12 tours that we need to consider in order to find the one of minimal cost. The other 12 are simply the reverse of these 12 for a total of 24 Hamilton circuits. Starting with our first tour, we go from A to B for a cost of $175, then B to C for $124, C to D for $168, D to E for $195, and E back to A for $130. This route has a total cost of $792. Now we look at the second route. Starting again with points A, B, and C, then traveling from C to E for $118, E to D for $195, and D back to A for $149. This route has a total cost of $761. Our third route begins with A, B, and D, so far with costs of $175 and $150. From D, we go to C for $168, C to E for $118, and back to A for $130. That means the cost of this route is $741, which is our best so far. I'll continue in this way and list the cost of each of these 12 tours. Now that we've listed them all out, we can find the optimal tour. The best option is to go A, D, B, C, E, and then A, or the reverse, the route A, E, C, B, D, A. So those are the 2 cheapest tours that this traveling salesman can take. Let's review the steps of the brute force algorithm. First, we made a list of all Hamilton circuits of the graph of Kn. In this case, it was K5. Then we calculated the total weight of each Hamilton circuit. In this example, the weight of each edge was the cost of the flight. And finally, we chose the Hamilton circuit with the least total weight. This method has obvious pros and cons. It does ensure that we have the cheapest route, or optimal tour, because we check every single option. But that leads us to the obvious drawback. This is a laborious process. In this case, we had K5, but what if this was K7? We would have 720 Hamilton circuits. Even cutting that in half, we would still have 360 to calculate. So while the brute force algorithm does guarantee us the optimal route, it doesn't guarantee that we'll have enough time to find it. And that will conclude this lecture video on the brute force method for calculating the optimal tour for the traveling salesman problem.